Hello, I'm Samuli Laato. I'm here to present our paper, Crowdsourcing Environment Data with Gamified Augmented Reality Minigames. First, data keeps us informed. So we need to know things such as how to get from point A to point B, where to build a road, how are the squirrels doing in my neighborhood, where should I buy a house, is our sewage system in need of repairs, is the climate warming up or not, are the city waterways polluted. So how do we get all this geodata? Well, first option is satellites. They are good for large-scale mapping, land cover, climate monitoring. Then we have aerial vehicles. They are more better for local scale, but still cover wide areas. They provide more granular data and detailed data. And street view cars, similar thing. And then finally, we have in-situ observations. These are local scale. They can be used to calibrate, validate sensor data, and provide typically the highest level of detail. In this paper, we focus on in-situ observations. Crowdsourcing has been implemented in various applications. We have, for example, iNaturalist, where we try to engage lay people. It was launched in 2008. It invites people to log nature sightings. Users record photographic evidence, but can also make notes of more qualitative observations. In return, iNaturalist provides users, for example, a catalog of what they have seen and auto-identification of discovered plants and animals. Then we have Google Maps, launched in 2005. It is a map service that integrates various data sources. Users can review places, add details, and fact-check information on Google Maps. And the service provides some level of gamification with badges, progression system, and a timeline, and catalog of visited places, and of course, navigation services. Then moving towards a more playful, gameful direction, we have Pokemon Go. It was launched in 2016 and it is a location-based game. Users are invited to submit new points of interest, gameful routes, and add information to existing POIs. One of the most popular games, Pokemon Go, still generates double-digit millions in monthly in-game purchases. The research problem that iNaturalist, Google Maps, Pokemon Go all face is that they all need to resolve two key challenges. First, how to motivate users to contribute the data to their crowdsourcing system. And the second one, how to guide users in a way that the data they provide is valid, useful, and reliable. In our context, we investigate like these two questions with LiDAR. LiDAR is something that's now included in iPhone 12 onward all end user models. And it kind of enables the creation of this kind of point cloud scan you see in the picture. It also enables more accurate positioning of augmented reality content, which is useful for AR game design. The research question we ask, when designing gamified augmented reality-based crowdsourcing applications that collect point cloud data, what are the key dynamics that influence user motivation and the effective guidance of data collection? Methodology was as follows. First, we designed these kind of 4 prototypes with LiDAR. And the idea was that during these prototypes, there would be a game and the data collection would happen automatically in the background. The first that we created was the spider game. So spiders move around and they need to be vacuumed in. And as spiders move away and all kinds of places, it encourages the player to move around, resulting in a wide scan. Then we had a scanning minigame. This visualizes the point clouds very concretely, and since players see the generated point clouds in real time, this hypothetically encourages them to fill in empty spots, resulting in high fidelity complete scans. Then we have the spray painting game. This is more artistic, so you can draw whatever on LiDAR surfaces. This can perhaps be more motivating due to creativity, but it is more difficult to predict what the outcome data would be like. And then finally, for comparison, we had the UFO game with the touchscreen controls. So here we can compare touchscreen control kind of minigame to those where the main operation is moving the device around. Then we did a user study. This is the overview. So first we invited all users to these kind of workshops where for 30 minutes we would present the minigames and the idea and the data collection and everything. Then participants, we would move outside. They would have the opportunity to try out the minigames 2 to 5 minutes per game. And then there would be a follow-up discussion afterwards where we would show participants the point cloud scans and we would kind of discuss together what they think about the entire activity. We invited selected participants for interviews and everyone completed this online survey. In addition, we had 3 other data sources, Think Out Loud recordings, field notes, and collected point cloud data. Then we had these are the survey questions for the interviews and the online survey. Participants were from Finland and Japan, and they were primarily students or staff in two areas, forestry or human-computer interaction. Analysis was done through reflexive thematic analysis, and all data was looked at together. Here are the findings. So theme number 1, some quotes from participants. I know some people who would want to engage with these kind of apps in nature. You would certainly engage some people with this, but I wouldn't want to engage with these kind of apps. So this was kind of a mismatch between nature and the app itself. And then another quote, in the UFO game, if there is a metaphor of picking up trash in the forest, it might help raise awareness about environmental conservation. So overall, I think users wanted the application to be better tied to the environment they were in. Then we had a few design guidelines based on this recommendation. And the second theme is that physical and environmental constraints remain fundamental hurdles. So these are hurdles we may not be able to bypass with the design consideration. For example, if we want participants to go to a very remote area, they will inevitably require like a four-wheel drive car to get there. It's not possible for us to address this with design. And this is also participants raised here some safety issues. And then we also again had some design heuristics like avoid a design that forces participants to excessively focus on their mobile devices. So kind of device where they need to focus on the environment and not the mobile device. Theme number 3, users seek meaning, justification, and a sense of purpose in participation. This was very important. So these isolated AR minigames didn't feel meaningful. And again, we have design guidelines related to kind of how to bring that level of meaning into the app design. Theme number 4, contributors desire having a selection of ways to participate. So not just this kind of single road straight ahead, but there's actually a need for participants to be able to express themselves and have some autonomy and freedom in deciding how to contribute. And again, design guidelines. Theme number 5, unclear goals and feedback undermine engagement. This was perhaps our shortcoming as designers because we didn't maybe make the goals very clear and the feedback wasn't immediate, so they only saw the point cloud scans afterwards. So these kind of things could undermine their engagement. And again, we have guidelines. Now, discussion, limitations. So the discovered themes and heuristics were connected to our solutions. The list is not exhaustive. More research is needed. Second, currently even many flagship Android phones are not equipped with LiDAR sensors, hindering wide-scale adoption of this kind of data collection. Future work, address the considerations heuristics in our own design. And after we've done that, we are planning on collaboration with location-based app designers for large-scale experiments. Thanks for listening. If you want the details, check out the full paper.